An EEG is a measurement of the mass electrical activity generated by hundreds of millions to billions of neurons in the brain. And EEGs are measured by placing a conductor on the surface of the scalp, and they pick up the activity of hundreds of millions to billions of neurons underneath, near the electrode. So the EEG is a measurement of the mass electrical activity of the upper layer of the brain, the cerebral cortex of the brain. This is kind of loosely speaking. EEGs are used medically in a variety of ways. An EEG is a gold standard for determining whether someone is brain dead or not. And EEGs also are necessary to determine whether someone has epileptic seizures. EEGs are also necessary for determining sleep stages, what's happening as you're sleeping, the different stages of sleep. EEGs are also used for screening for general brain abnormalities. Could be due to a stroke or a tumor or all kinds of sources of abnormal brain dysfunction. EEGs are not specific, but they're very sensitive. They can tell you something's wrong, not necessarily what's wrong. You know, a thought lasts about as long as a snap of a finger, but it isn't a unitary thing. A thought has many subcomponents to it, and with precise kind of EEG measurement called an evoked potential, we can see the different stages of information processing as you're having a thought, from the breaking down of a sensory stimulus to the actual perception of it, to the integration of it with your ongoing model of what's going on inside and outside you. Sometimes you can see the actual making of a decision, certainly the movement of the response. So EEGs are a way to get a handle on the microstructure of thought in the brain. So there are many startup companies now all over the world, especially in the US, that are using EEGs as controllers for video games. And they're using different more or less simple or complicated technologies. Basically, they're measuring EEG. And they're doing this because of the allure of having a direct thought command, like in science fiction movies where you think something and then an object moves in your environment around you. Your thoughts directly affect material reality without the intervention of your fingers. And that's kind of exciting. So that's why I think there's so much interest in it, in using EEG for video games. Well, it's a little early, actually, to be moving EEG from the laboratory into consumer games, I think. And the problem is that when you put a sensor, an electrode, a wire, on top of the scalp, it doesn't just pick up the activity of neurons in the brain, it also picks up activity generated by movement of the scalp muscles, by eye movements, blinking, jaw clenching, head moving. These are called artifacts, and they're electrical signals. They look sometimes indistinguishable from a brainwave signal that comes from the brain. And the problem is that it's very difficult to get rid of them. It's really difficult to get rid of them, to recognize them and then to eliminate them. Very, very difficult. So when we use the EEG medically, we're very careful about these other sources of contamination when we measure a signal at the scalp, and we go to very, very great ends to eliminate them, so we know we actually are measuring electrical activity in the brain. And this can't really be done now in a completely ordinary situation on a routine basis while someone's playing a video game. It just isn't possible now. Yeah, so you might think that just having a game, it doesn't matter whether it really works or not. It doesn't really matter whether the signals really come from the brain. It's just a toy. Who cares, right? Well, the problem is that the perception is created in the public.